Okay, so can you hear me? Okay, so hello everyone, welcome. Can you hear me properly?
Yes, I can hear you.
Okay. So just we are waiting 1 or 2 minutes for joining all of those other participant. Then we'll start our today's session.
Okay, no problem.
Okay, so now we'll start our presentation. So I hope all of you already get our recorded video class and also get the practice code. Okay, so basically today is second day. So mainly for the second days, I try to discuss about that filtering and displaying the satellite images. So mainly Landsat and Sentinel image, how we can easily filtering and displaying, and how we can easily use the different types of satellite composite, okay, as well as how we can easily use the different types of band combination, and after that how we can easily export the satellite images, Landsat Sentinel modis from the Google Earth Engine platform, as well as talk about the import, filter, reduce, clip, and display the raster data in Google Earth Engine platform. We also talk about the time series chart of NDVI using ready-made dataset, as well as also unready-made dataset, mainly which are not ready for that band. We'll talk about that and how to export any shape file from the Google Earth Engine platform. Okay. So today's session, I will try to complete all of those topic one by one. Okay, so let's go. So we already know about the Earth Engine public data catalog. So mainly in this Earth Engine public data catalog, we can easily access lot of remotely sensed data such as Landsat, Sentinel, MODIS, different types of train dataset, land cover dataset, different types of atmospheric dataset. We can easily access from the Google Earth Engine platform. Okay, so today, first of all, we try to discuss about the filtering and visualizing the satellite images in Google Earth Engine platform. How we can easily filter and visualize different types of Landsat or Sentinel, this type of image. So basically, when you want to filter the image collection in Google Earth Engine platform, mainly it depends the three factor. First factor is that your region of interest. Suppose I need the satellite image of Landsat for the Dhaka city or any specific boundary. Okay, so this is the first factor for filtering. Second factor is that image metadata filtering. Suppose I need the image, which image will be not more than 1% cloud cover. So it is the another factor for filtering. And last factor is that specific time period. Suppose the image for year of 2017. I need the image for year of 2017, month of January. Okay. So basically it's totally different for the specific time period. We talk about that. So mainly when you want to filter this image collection, it's different on the some factor, such as it mainly different on the specific region, and it also different on the filter metadata. Okay, suppose I need the image, which image will be not more than 1% cloud cover, or I need the image for the specific time period, year of 2017, month of January, February, or dry season, rainy season, or in a specific time period. So now, so practically talk about that, how we can do the filtering about that. So just I open a new code editor in my browser. So first of all, I need to import the satellite images. So first of all, I simply can see the browse data catalog. So simply click on here. So now it's opening the whole catalog of Earth Engine. So here we find out all of those image collection. So from here, suppose I want to show you the for Landsat. So just simply click on the Landsat. So here I can get all of those Landsat image collection. You can see Landsat 9, Landsat 8, 7, 5, 4. Okay, all of this Landsat image collection for the different time period we can get from here. So in this time, suppose I show you for the Landsat, but all of those for the filtering for the same process. When you want to filter the image collection for Landsat 7 or Landsat 5 or Landsat 4 or Landsat 9 is the same approach when you want to filter it. So in this time I talk about the Landsat 8. So just simply click on the Landsat 8. So here I can get the some images such as surface reflectance. I also get for the top of atmospheric and also get the raw image. Okay, so basically it's the raw image. Using this raw image, it created the top of atmospheric, also create the surface reflectance. Okay, so basically we are work for the surface reflectance or top of atmospheric. Sometimes raw image will also need. Okay, so in this time, suppose I want to work for that top of atmospheric. So just click on here. So now I can get all of those top of atmospheric image collection details such as dataset availability. Okay, so basically you can see we can get the dataset for year of 2013 to 2023. So this time period we can get the dataset for that Landsat 8 top of atmospheric reflectance. And dataset provider is that you can see we are GS Google, and this is the snippet. Okay, so basically snippet is that unique ID. So all of those image collection or all of those dataset have a unique ID. So in this time, this is the unique ID of the Landsat 8 top of atmospheric image collection. Okay? As well as we are also get the some description about that how they create this dataset. Here you can see it already show about the top of atmospheric reflectance, and already all of those atmospheric correction, all of those things already done for this dataset. So when you want to use the dataset, in this time we don't provide any types of atmospheric correction or other types of correction, don't need because it already done. So in this time I want to use this dataset. So first of all, this dataset I need to import in my code editor. So there are the two way. If you want, you can simply search top of the code editor. You can simply search the Landsat, and then you can also import. In this time I just simply copy. Suppose I simply copy that. Simply copy the unique ID or snippet ID. Simply copy and paste on my code editor. Simply paste. Okay. So now give a variable name. You can put any variable name. Suppose I put the variable name is that L8. Okay. So now it's a full image collection. This full image collection is stored in a variable. This variable name is the L8. Okay. So now I want to check how many images are available in the Landsat 8 top of atmospheric from year of 2013 to 2023. This time period, how many images are available? So simply use the print function, print, then call the variable name L8 because this variable stored this full image collection. Okay. So now I want to computing how many images are available. So just use a function, size function. Okay. We already know about the size function. Mainly this function computing how many images. So now click to the run. In this time, it's computing how many images are available in the Landsat 8 top of atmospheric between this time period, year of 2013 to 2023. Between this time period, how many images are available for the whole world? Okay, so now it's computing. Okay. So now you can see it computing very large number, more than 1 million images for the whole world between this time period, year of 2013 to 2023. Okay, for the whole world. So now this is my total image collection of Landsat for the whole world. But in this time, suppose I don't need for the whole world. I need only for this Landsat 8 image collection for the specific boundary. Okay, it can be Dhaka city or other any boundary. Okay, so in this time, suppose I need this image collection for the Dhaka city. So first of all, I need to import the Dhaka city boundary. Okay, so previous class we discussed about that how we can easily import the shapefile. Okay, so in this time I simply import the Dhaka city boundary. So simply click on here, import. So now you can see it will import it, and default variable name is the table. If you want, you can easily change it. Suppose I put the name is that ROI. You can put any name, no problem. In this time, this image collection for the whole world, but in this time, I don't need for the whole world. I need only for the Dhaka city boundary. Okay. So for that, I just simply take a variable. I put the variable name, suppose filter region. You can put any variable name. So in this time, this image collection for the whole world, but in this time I need for this image collection only for the Dhaka city. Okay, so this image collection already stored in a variable. This variable name is the L8. So simply copy the L8 and then use a function, this function called the filter bounds function. Okay, so mainly this function intersecting the full image collection only for the region of interest of Dhaka city. So now here you can see what is the argument. Argument is the geometry. Your boundary. What is your boundary? In this time, my boundary is the Dhaka city. And I put the Dhaka city variable name is the ROI. I just simply put here ROI. So now let's check how many images are available for Dhaka city. Just use the same function print and simply copy the filter region, paste and use that the size function and click to the run. So now it computing how many images are available only for the Dhaka city. We can get 426 images are available. Okay, so now this is the 426 image is available for the Dhaka city boundary. And what is the time period? This is the time period, year of 2013 to 2023. This time period, we get the total 426 images for the Dhaka city boundary. So in this time, suppose I filter the image properties. And what is the image properties? We can get the image properties. You can see image properties, different types of image properties, cloud cover land, collection category. So in this time, suppose cloud cover, I need only for this image, which image will be not more than 1% cloud cover. So from 426 images, I need only for this image, which image will be not more than 1% cloud cover. So this is my target. Okay. So for that, in this time, I just take the another variable. Suppose filter metadata. Okay. So now from 426 images, I need only for this image, which image will be not more than 1% cloud cover. So this 426 image already stored in a variable. What's the variable name? Filter region. Simply copy and paste here. And now use a function filter metadata. So mainly this filter metadata function filtering image properties. So in this time you can see what is the argument. Argument is the name, operator and value. So in this time, what is the name? Name mainly image properties name. You can see image properties name. In this time, I want to work for the cloud cover. Simply copy the cloud cover and paste
Sir,
here.
excuse me, sir.
Yeah, please.
So can you please explain the description also of cloud cover?
Okay, so in this time, I need, suppose in this time 426, it stored all of those cloud cover percentage, such as here you can see. So mainly is the percentage cloud cover 0 to 100. Okay, so it can be 0 to 100, this value of the cloud cover, and negative one not calculated. In this time, this is the range about that. Okay, cloud cover range. Suppose 0 to 100%. This is the range about that cloud cover. So in this time, 100% is the fully cloudy, and 0 is the lowest value. Okay, so 0 is the lowest, and 100 is the highly concentration of the cloud. Okay, so in this time, I need only for the, suppose less than 1%. I need. So for that, in this time, I just simply copy the cloud cover. This is my property name. I simply set the property name cloud cover, and then set the operator. In this time, I set the operator is that less than. Suppose less than, and set the value. Suppose sometime. Okay, so it's different. Suppose I put the 1%. Sometime I now want to check how many images available for the less than 1% cloud cover for the Dhaka city. Then I explain. Just a minute. So simply copy the filter metadata, and then size function. So now it computing how many images is available for the Dhaka city, which is the less than 1% cloud cover. So here you can get the low image collection now, 64. Okay, so this 64 image is the less than 1% cloud cover. Suppose I need here the 5. So now this value is also increased. So in this time we can get that for the Dhaka city, less than 5% cloud cover, we can get the 111 images. So in this time, suppose you want to, suppose I put here the 1. So now it provide only for the less than 1% cloud cover how many images is available. For the Dhaka city, I got total 64 images. But when you want to work for the coastal land or river bank or other cloudy region, such as coastal as well also river bank, then when you want to put at the 1, sometime you can get the 0 image. Okay, when you can get the 0 image, it means that for this region less than 1% image is not available. So for that you have to increase the cloud percent level value. You can check the 5% or 10% or 50%, and then check it. Okay,
so what is the ideal cloud cover value?
Okay, so basically ideal cloud cover value is that we have to need the clear image. Okay, suppose less than 1% is okay. Okay, suppose less than 1% is the ideal value, but sometime when you want to work for that coastal or river bank, then less than 1% is not available. Then you can simply check it, 2% is available or not, 3% is available or not, 4% is available or not. Okay, then you can take the images. Okay, but when you want to increase the value, then some cloud is added on your satellite images. But in Google Earth Engine platform, we can easily remove this type of cloud also. Okay, suppose you want to for the coastal land, you add the suppose 90%, less than 90% cloud cover is available. But when you want to add the 90%, then some cloudy pixel or white pixel you can get on your satellite images. For further, we have also need to remove this type of pixel in and using the cloud mask band function. Okay, so this process I will show you the further class how we can easily remove the cloud and get the very beautiful image. So in this time, this ideal value is that we have to take the very clear image. Okay, so in this time I choose the less than 1% for my study area Dhaka city. Less than 1%, very less cloudy image we can get for that. And I want to check how many images I can got. I can got total 64 images, less than 1% cloud cover. Okay, so now this is the 64 images. And what is the time period? This time period is that year of 2013 to 2023. But in this time, I need for the specific year or a specific season or a specific summer season, rainy season, or any other time period I need for the specific time period. Don't need for the whole time period. So for that, we have to use the another function, this function called the filter date function. So just take a variable. Suppose I put the variable name is that filter date. And now from 64 images, I need only for this image, which image is available for the year of 2000, suppose 22. I need only for the image year of 2022. So this 64 image already available in a variable. What's the variable name? Filter metadata. Simply copy and paste. Then use the function filter date. Now put your start date and end date. You can put any season or any time period you can put. Suppose I put the time period year of 2020, 1st January from year of 2020, December 31. So now I want to check how many images is available. So just simply print and filter date and use that the size function and click to run. So now it computing how many images is available between the year of 2020 for the Dhaka city. Here I can get 7 images. Okay, so this is my final output. Here I can got 7 images. And what is the properties of the 7 images? This 7 images is available for my Dhaka city region. This 7 images is the less than 1% cloud cover. Okay, so now if you want to check about that, this 7 images, all of this information for their acquisition time, all of those things. So for that, simply print the filter date. So now we can get all of this information about that total 7 images, all of those acquisition time, all of those things we can get from here. You can see total 7 elements means 7 images and 17 bands we can get for all of each images. So here you can see the feature. So from here you can easily get all of this images time. You can see first image is the 11th of February, 26th January, 11th February, 30 March, 27 December, 9th November, 9th November. We can get all of those images. Acquisition time. Basically it is a single image. Okay. So in this time, sometime when you want to work, we need some suppose single time period image. Suppose we need for the year of 2020 a specific date image. Suppose it is a single date image. Suppose year of 2020, 11th February. It is a single date image. So in this time, I want to work this image. Okay. So for that, how we can easily create the single date image. So for that, simply copy this ID. You can see this is the ID. Simply copy. And then just take a variable. Suppose I put the variable name is the image. And use the function ee.image and paste here this ID. Okay, so now it visualize this time image, year of 2020, 11th February. This image now visualize for my study area. So now simply put here map dot add layer and add this layer of this image, click to the run. So now you can see it added the layer, add a layer, but did not focus. So just I simply focus using the map.center object function. So object is RY and put here the suppose 10, click to the run. So now it's visualized about the single data image of the study area. It shows as a tiles. And these tiles acquisition time is that year of 2020, 11th February. So in this time, it has another problem. This problem is that these tiles is not fully cover my region. Suppose I also add my shape, layer for my study area of ROI. So further, I simply add a layer of my study area. So just use that map dot add layer, and my study area is that ROI. Click to the run. In this time, it's added the layer of my shapefile boundary. Then we can easily get the visualize it will be fully covered or not. So you can see this is my study area. And this is the tiles which is captured acquisition date is the year of 2020, 11th February, but it not fully cover my region. Okay, so this is the problem about that. So now let's check the another tiles. What's happened for the another single data image time. So just simply click on here and feature. Suppose I try to check it, simply copy this ID and paste here. So now check about this condition about these tiles. It's the fully cover or not. Okay, so it's perfectly cover my study area. Okay, so this is my study area and this the tiles is fully covered. So now further in this time, you can simply clip these tiles for your study area. So just use the function, clip function. So use here the clip with your study area, ROI, and click to the run. So now I can get this image only for this boundary. You can see I can get this type of image. In this time, it shows the default color, okay, without any kinds of band combination, normal band combination. So now we're going to set here the different types of band combination and visualize this image. So for that, for the adding the band combination, you can simply click the layer for the image layer, click on here, and here you can see this the all of those band we can easily set in here. Suppose I set the red, then green and blue band for the true color, and then it's just 98%, then apply. So now we can get the true color composite, true color band combination you can see for this satellite images we can get. Okay, and from here you can easily create any types of band combinations, such as you can see near infrared, red, blue. Suppose you apply. So now you can get this type of band combination. As well as you can easily use the different types of band combinations, such as suppose shortwave infrared one, near infrared green. So you can easily use the different types of band combination from here. Okay, and mainly we are using the different types of band combination to identify the different types of feature from this image. So in this time, suppose I use the natural color. So put here the red band and green band and blue band. Apply. So now you can see we can get the true color band combination. And now this visualization, I need to import in this code editor. Okay. So here you can see the import button. Click on the import button a new line of code added in the code editor. Simply copy this variable name, and we already know about that. After the object name, we always put here the visualization parameter. So visualization parameter. After we have to use here the layer name. I put the layer name, suppose true color. You can put any name. So now this visualization is set it in my map, and also set about the, you can see the true color layer name. Okay, so first is the boundary layer, and second is the image. Secondly is the image. So this is the image, and this image is only for the single date. Okay, so mainly this image acquisition time is that year of 2022, 6 December.
Sir, can we also
Okay,
increase the
26
resolution
January.
of our study area?
Which one? Yeah, please.
Sir, can we also increase the resolution of our study area?
Yeah, for that you have to use there the pen sharpening technique for Landsat. Okay, when you want to work with for the suppose Landsat, mainly it's the resolution is the 30 meter, but when you want to apply the pen sharpening, it will be 15 meter. We can get 15 meter. Okay, in this time we can get the pixel size is 30
Sir,
meter.
how to do that?
Okay, in this time I not talk about that. So further I discuss about that. Okay, pen sharpening technique. Mainly pen sharpening. This method is that we have to use at the panchromatic band. You can see panchromatic band, and this result is the 15 meter. Okay, so using this panchromatic band, we are applying here the pen sharpening technique and increase the resolution 15 meter. So it is also possible for do that. Okay, so in this time, anyone in question about that, you can ask me. Okay, so administrative boundary.
Sir, I have a question.
Yeah, please.
When we work with some specific time range, for example, January 2020 to March 2020, then can we get each day images from Landsat?
What's the time period?
1st January 2020 to 1st March 2020.
Yeah, you can also get the image, no problem. So just you can simply change here. Suppose I also show you that. Suppose put the time period 1st January 2022. 1st January from March 2022.
Yes.
March was 30. This time period. So now click the run. In this time, we can get this time period, how many images we can got. So first of all, you can check about that, this time period. It's not, it's the single another time period image. So just I simply. So just simply put here the year of 2020, 1st January from March.
Sir, can we get the each day image? For example, January 1st day to each day. For Saturday, Sunday, Monday.
Okay, so basically in this time it's not possible to that because is the temporary resolution is that 4 to 5 days or 10 to 12 days about the Landsat image collection. I think the Sentinel for the 4 to 5 days. Okay, so for the each day is not possible to do that.
Sir,
Yeah, please.
sir, if we want data for one day, so what will be the start date and the end date? Like if we want to get the data for Saturday or 1st January, so what will be the start date and the end date here?
Okay, so you need the data for
1st January.
Yeah, 1st January.
1st
So
January 2022. So what
okay.
will be the start date and the end date?
So in the another problem is that first of all you have to check this time image for this time, is it available for your satellite image or not. Suppose you need for the only for the 1st January you have to need the image. Okay, so you can simply put here this time period, and now check this time period we can get total 7 images. Okay, and you can easily check about this or this total 7 image acquisition time. Okay, so for this area of Dhaka city we can get year of 2020 whole year we can get total 7 images. Okay, and this 7 image is what is the acquisition time about that, so you can easily check it from here. Suppose you can say the first image is the 16 February, 4th March, 20 March, 31 January, then 16 February, 4th March, okay, 20 March. Okay, so basically it's the acquisition time about that. Okay, suppose
So
you need the
we have
1st
to
January
check
image, but the 1st January there is the no image for your study area. So for that you have to check it. You can put the time period and then take it from here. Which image is available for your study area? Okay.
I understand. Yes, sir.
Okay. So suppose in this time for this Dhaka city, for this time period, I can get this type of image is available for that. Okay. So I can just only use this type of image and make the analysis for the further and also export this image.
Sir,
And
how to identify which data we like, what like when to use Landsat, when to use Modis,
okay.
how to identify that?
Okay, so for that, it's mainly difference between the resolution. Okay, so for that, for the suppose Landsat is the 30-meter resolution, and Sentinel is the only for the 10 to 12-meter resolution. Okay, 10 and 12 between this resolution. So when you want to work for the high resolution, we have to use here the Sentinel. Okay, but Sentinel has another limitation. This limitation is that you did not get the pass time. Okay, but Landsat is also give you the pass time. Sentinel is available only for the year of 2015, but Landsat is available for year of 1973. From 1973 we can get the Landsat data, but Sentinel is only available for year of 2015. But Sentinel is a very high resolution than Landsat. Okay, so it's mainly suppose when you work for the high resolution for the present time you can easily use the Sentinel, but when you want to make for the temporal change analysis or other types of historical analysis, then you move to the Landsat image, such as because we can get the Landsat image for 1973 and Sentinel we can got for 2015, but Sentinel has a high resolution, Landsat is the low resolution. Sentinel mainly 10 to
And sir,
12.
Modis?
Yeah, and Modis mainly we can use for year of 2000. Okay, and Modis is also bad resolution than Landsat. Modis is the 250-meter resolution. Some dataset is also 1000-meter resolution. Different types of dataset has different types of resolution. Okay, mainly freely we can get for the Sentinel is high resolution for the freely, as well as if you want you can also use there the different other types of satellite image such as Maxar satellite image, as well as you can also use here the sport satellite image. So it's very 0.3 centimeter resolution, it is very high resolution, we can easily use it. As well as you can also use here the drone image for this, then we also get the very high resolution, but freely available for the Sentinel is the best or high resolution. First of all Sentinel, then Landsat, then Modis resolution when you compare these things. Okay, okay, so I hope we can got my point. Yeah, any question? Okay, and okay, so in this time here you can see we can get this single time period image, and basically first of all you can simply put your time period. Okay, and then check for this time period how many images are available and what is the acquisition time for this image. Okay, then you can easily got it for that. And mainly Sentinel-1, this is the temporal resolution or single satellite image for the 12 days for the Sentinel-1. And Sentinel-2 is the 10 days. Landsat we can get for the 16 days. Okay, suppose you can get this is the time period, interval time period. Suppose you need for the each image first day, second day, third day, it's impossible because the temporal, it's different on the temporal resolution. Such as for the Sentinel, we can get the temporal resolution is the six day. Okay, and then Sentinel 2 is the 5 days, Landsat 7 or Landsat 8 is the 16 days. Okay, so I share with you and just okay, so as I send you a message, you can see your WhatsApp group, then you can easily get the idea about that. For the temporal resolution, when we can what is the difference between this. Okay? So temporal resolution, you can get the Sentinel 1 for the 6 day, Sentinel 2 5 days, Landsat 7 8 16 days. Okay, Terra we can get the 16 days. Okay, so it's very different. So that's why we did not get the image for the each day. It's different on the temporal resolution. Okay, and this is the process when you want to show the single time period image. Okay, so simply copy this ID of this image and then simply take a variable and put here the ee.image and give this put the ID. Okay, then simply add the image on your study area and you can simply use the clip with your study area, then you can get the single time period image. So it's possible for the small region. Okay, but suppose I need the satellite image for the whole country boundary of Bangladesh. Okay, suppose in this time my study area is that Bangladesh, total whole country boundary of Bangladesh. So just I simply import the Bangladesh country boundary shape file. Suppose, yeah, just I simply import that Bangladesh country boundary shape file. So Bangladesh country boundary shape file is not possible to use only for the one tiles or one image is not capture the whole boundary of Bangladesh. It's not possible because it's a big area. Suppose I in this time I simply display the layer. Suppose I put the layer name of Bangladesh boundary is that, suppose BD. Okay, suppose I put the BD and I want to need the satellite image for the Bangladesh, whole Bangladesh boundary. So in this time the single tiles is not possible. Suppose I want to use here this type of single tiles, then it's not possible. It's not fully cover my boundary. So for that, in this time I need to create the composite. Okay, so let's go about that, how we can really create. Okay, so this one I don't understand about that. Okay, so basically satellite image mainly it's depend on the resolution. Okay, so which one is the best resolution, you can use it, then any kind of area it is suitable, no problem. Such as Landsat, Sentinel. Okay, Sentinel is the best resolution, we can get the freely, then Landsat, then Modis. Okay, so in this time suppose I need this satellite image for the whole country boundary of Bangladesh. Okay, so in this time just I simply change it. Suppose I just simply put here that BD. I just simply use here the filter bounds with BD. Okay, and now I just simply put here the time period. Suppose I need for the 1 year. Suppose put here the year of 2020 or put here the year of 2022. Suppose 1st January from December 30. So this time period I need for the image. Okay, just I filtered the date. So now I check how many images is available for the whole country boundary of Bangladesh. So now let's check. Okay, in this time we can get the 61 tags or 61 images are available for the whole country boundary of Bangladesh. 61. So in this time, if we want to check about the acquisition time for all of those images, we can easily get from here. We can easily get from here. Suppose you can see all of those images one by one. Their acquisition time also included in here. So in this time, suppose I want to work only for the single image. Okay, suppose this image I want to use. Simply copy. But when you want to display these tiles, it's not fully covered. Okay, you can say I simply put paste in here. So now it show about the what is the tiles about that image. Just I simply show the layer. So now click to run. Okay, you can say I can get the tiles look like that. Okay, so single tiles is not possible for the Bangladesh boundary. One single tiles because it's a big region. But when you want to work for the small region, then you can easily use the single tiles. But in this time, I want to need this satellite image for the whole country boundary of Bangladesh. Okay, so in this time, I need to create the composite. So in this time, I need to use all of those image collection. Okay, suppose here I can got for the 61 images. So now I want to use the total 61 images and create the suppose median composite. So what is the median composite? So mainly median composite calculated the middle pixel value and create the composite. Okay. So in this time, there are any kinds of other tiles. We can also check about the other tiles. Any kinds of tiles is not covered. The full country boundary of Bangladesh is not possible because it's a big region. So for that, in this time, I need to combine all of those images using median value. So in this time, I create the median composite, then it will be fully cover my study area and I can get the satellite images. So now how I can create the median composite. Okay, so let's go. For creating the median composite, first of all, I'm just commenting that it's not need for this time. Just I take the variable, suppose final image and simply copy this variable and filter date. Okay, because this filter date is stored total 61 images. Okay, so now I want to create the 61 median composite. So just use here that median. And now first of all, I will show you that result. Suppose map.add layer and call the final image. Copy and click run. So in this time, all of those total 61 tiles join and create the middle pixel value and create this composite for the whole country boundary of Bangladesh. You can see we can get this type of result. You can see in this time total 61 tiles. Okay, you can see it fully cover my study area. Okay, so now I just simply use here the clip function. Just use here the clip with study area is that BD. Now click run. Okay, so now I can see it just clip with my study area and I can get this image for the whole country boundary of Bangladesh. So now from here, I can easily set the band combination and now we can easily use the median composite and easily make the different types of remote sensing analysis. Okay, so mainly when you want to work for the big region, which region is not fully covered, the one single tiles, then we have to use this type of median composite you need to create. Okay, so in this time, all of those images, middle pixel value create this composite. So now you can simply set the color, suppose red, green, and blue, 98%. It takes some time because it's a big image for the whole country of Bangladesh. So now it's trace and find out the minimum and maximum reflectance value. Okay, done. So now apply it. Now it's added. And now we can easily get the whole country boundary Landsat images for year of 2022. Okay, and what is the acquisition time? In this time, this acquisition time is that all of those images, total 61 images, middle pixel, we can use it. You can see it. And now from here, you can easily download this image. And you can, if you want, you can also use that. There are a lot of other remote sensing analysis for the whole country boundary of Bangladesh, such as land use, land cover, NDVI, or other types of work you can easily do. Okay, so basically this is the use of median. Suppose your region study area is the very big, then you need to just at the same time you want to show the image for the big region, then simply use at the median. So in this time, this total 61 images, middle pixel value create this composite for the whole study area of Bangladesh. Okay, but for the small region, you can easily use the single data image. Just you can simply take this type of single ID of this image and work with that. Okay, if you want, you can also use here the median composite for the also small area. Same process. Suppose you can create for the Dhaka city all of this image. You can create the median composite. Okay, then you will also get the better image when you want to use the median composite. Okay, so this is the process for how we can easily visualize the image for the big region and also single data image. So in this time, it's a single data image. Okay, but in this time it creates the median composite from total 61 images. This image. Okay. Okay, so in this time here you can see here I write the code for filter bounds. I take a new variable, filter metadata. I also take the new variable, filter date, also use the new variable. But if you want, you can just take the single variable, and under this variable you can put all of those function one by one. So then it also shortens your code. So I also show you the process. So first time I write this type of code for your understanding. So just I simply commenting all of this code. So in this time I just take only for the one variable. Okay, and then under this variable I put all of those function one by one. So first of all, I just take a variable, suppose image. Okay, and under this variable I put all of those function. So I call the image collection LA, filter bounds with my study area, suppose Dhaka city RY. Okay, and then put here the dot filter metadata for filtering the image properties. Put here cloud cover, suppose less than 1%, and then put here the filter date function for a specific time, year of 2000, suppose 22, 1st January, from suppose any time frame you put, suppose 2022 or December 31. Okay, then in this time it's done. Okay, so in this time, this is the process for filtering. Suppose first factor is that where you need this image, then second factor how, then third factor is that when. Okay, so mainly first of all, this image where you need. In this time I need this image for the Dhaka city, and Dhaka city is already available, stored in the variable RY. Then how mainly in this time I need the image only for the less than 1% cloud cover. Okay, I put here the one, less than 1%. And when is the specific time period. So mainly where, how, and when you want to use this type of function. For the where, we need the filter bounds function. How, we need the filter metadata function. When, we need the filter date function. Okay, so now it creates the image collection. Okay, so final image collection how I can get. So just use here the print and use here the image and use here the size function. So now it show about the final image collection. for year of 2022, we can get the image collection for the 9. Okay, so 9 image collection for the Dhaka city, because I use here the ROI. ROI mainly studied the Dhaka city. Okay, and BD studied the Bangladesh boundary shapefile. I use here the ROI, so that's why I can get the 9. But when I put here the suppose BD, suppose I just put here the instead of the R, I put here the BD mainly Bangladesh boundary. Click to the run. In this time I can get for the less than 1% cloud cover how many images is available for the Bangladesh boundary. So now it also increase the value. You can get 61 images. Okay, so this is my image collection about that. If you want to check about that, suppose acquisition time, simply use at the print, then check about the every single image acquisition time. So just use at the image and click to the run. So now it show you that all of those images acquisition time, total 61 images acquisition time. So now further, if you want, you can also use the single date image, or if you want, you can make the median composite, anything. Suppose I put here the ROI, and click to run. So now I can get the image collection for the Dhaka city. I can get the Dhaka city for the 9 images for the year of 2022, and I can easily get all of these images acquisition time from here. Every single image acquisition time we can get from here. You can see the 16 February, 4th March, 20 March, 31 January, 26 February, 4th March, 20. So all of the images I can get from here. So from here you can simply use the ID and show the single date image. Okay. Or if you want, you can create the median composite. Suppose I use the all of those 9 images, middle pixel value, and create the median composite. So just for use here the dot median, it create the median composite. Okay. In this time you want to check about that. In this time it show about that image size is not a function. Okay, it's very important about that. When I use at the median function, then this size function is not work. Okay, because when I put at the median, then this image is only for the single image, not image collection. Okay, this size function is only work for the image collection. But when I put at the median, then it's not a image collection. It's just a single image. Okay, you can see without median, it will be work well. There is no problem. But when I put at the median, then it's not a image collection. Then this variable will be a single image which is created from total 9 images. Okay. So now I just simply use here the clip function. Use here the clip with my study area. Suppose Dhaka city ROI. So now visualize it. Just simply map.add layer function. Map.add layer. And the image, click to the run. So now it visualize about the Dhaka city image collection. Okay, you can see it added. So just I add here the visualization parameter. If you want, you can simply add here. Just click on here. And then add here that band 4 was band 3 to custom 98%. And apply. Now we can get this image collection. You can see in this time when I use the median composite, then we will also get the better image, because in this time this image is created from total 9 images middle pixel value. So that's why in this time we also get the better image than a single date image. Okay, so in this time you can see it also look better than single date image because it created from total 9 images middle pixel value. Okay. So now we can easily use this image and extract the different types of information such as land use, land cover, vegetation, water body extraction. A lot of analysis we can easily do from here. Okay, so in this time, anyone any question about that, you can ask me about question. Any question? Basically, we can write only for this code, okay, for filtering and visualization. But first time I write all of this code for your understanding how it will be work one by one. Yeah. Okay, so because I need the less than 1% cloud cover image, because less than 1% is the better. If you want, you can also check about that 0% is available or not. So our main target is that creating the very good image. Okay, so in this time you can put for my study area less than 1% is okay. So if you wanting to check about, suppose I simply put at the less than 0%, or suppose 0.2% is available or not, click to the run and check about that. So our main target is that we have to choose the very less images, okay, and then work with that. This is our main target all time. So I use at the less than 1%, so now I can get this type of image. And now it also better about that one. Okay, in this time it's about the uh, less than 2%, okay, or 0.1. You can check about
If
that.
metadata represent the cloud cover percentage,
Yeah.
so when always I calculated the cloud cover percentage, I used metadata
Yes.
function.
Yes.
Filter
Filter metadata function mainly used for the filtering the cloud cover. And this
cloud
value
cover.
all time you set, try to use at the low value, because we need the very very clear image. Okay? Suppose I put at the 90%, then it will be lot of image with their cloud also count in my image, and I did not get the better image when I put the 90. So all time less than 1% or less than 0.1. So actually the lowest value of the cloud cover.
Sir,
Yeah, please.
suppose we want to cut down the cloud cover or set the cloud cover value for Moody's data. So, can we use the filter metadata function there also?
For Moody's data set, I think filter metadata function is not work for that. Okay, so basically, Moody's data set has a, suppose Moody's data is two type of data we can get. Moody's product. Okay, mainly in this time in Google Earth Engine platform, you can see the Moody's product. So it's already give you some product such as yes, this is the Moody's data set. I think you can also use this data set about the adjusted reflection daily 500 meter. So it's the one kind of Moody's data set. And you can see here, there is the no image properties. So there is a no image properties. It's only available some band. Suppose band 1, band 2, band 3, as well as term of use you can see. In this time, there is no about that image properties value. The image properties value we can only get for that Landsat and Sentinel. But for the in this time, for cloud cover, for the Moody's, is not possible to remove from here.
So we can use the cloud cover function to extract to cut down the cloud cover for Sentinel and the Landsat
Yeah,
only.
Landsat. But Sentinel is the another name about the image properties. You can see the Sentinel is called the cloud coverage assessment. You can see the properties about the Sentinel-2 multispectral instrument. Was top atmospheric. It has the another name about that image properties. You can the image properties name is that cloud pixel per sentence, as well as the cloud coverage assessment. In this time we have used the same name. Okay, so which image properties? So in this time for the cloud cover for the Landsat, this image properties name, and cloud pixel per sentence is for the Sentinel. Okay, but other things will be same, less than 1% or 2%, which you need. Just simply put in.
So we can use it for Sentinel-5 also, the cloud percentage.
Okay, Sentinel-5. No, Sentinel-5 is the product. Mainly, this Sentinel-5 is provided with the air quality parameters dataset, such as it's already removed all of this cloud and create the better image, and already create about that different types of air quality parameters. You can see it's a tropospheric instrument, and mainly it collect the data for the air quality parameters. Okay, in this time, non need put here that's this type of things about that for the filter metadata. In this
So
time,
for NDVI calculation, which satellite we use?
For the when you want to work for the better resolution, Sentinel-2 is better.
Hmm.
Okay. Suppose,
No,
but
sir, I asking
yeah.
you that for NDVI, which satellite we will use?
Okay, for
Should
you can
use for
use any
anything.
satellite image. If you want, you can use there the Modis. If you want, you can use there the Sentinel
Hmm.
or Landsat. Okay, is possible to calculate
Hmm.
for the NDVI any satellite image.
Yeah,
But for the
okay.
better resolution, Sentinel-2 is
Hmm.
better. Okay, but for Landsat, we can get the past time data. Okay, so that's why when you want to make the change detection for the past time, then it's the better to use here the Landsat.
Sir, if I use the Sentinel 2 for NDVI calculations, I think it is necessary for removing the cloud cover for
Yes.
get a clear image for my region of interest.
Yes.
So, how can I remove the cloud cover for Sentinel 2?
Okay, I show you the one by one. So I think it will be covered for our next third day's class
Okay.
for that. For
Okay.
that, okay, you can see the third day. We talk about that satellite image using Landsat and Sentinel. For the Sentinel, how we can easily use and remove the cloud. These type of things will be covered one by one, no problem. Okay, it was possible to do that, no
Okay.
problem. So now I simply set the band. Suppose red, green, blue. Okay, so now we can get this type of image. Suppose now I want to use this image and make the NDVI map. Okay, Sentinel is also same. Okay, you also try to Sentinel, but I also show you the for the next class about that how we can easily work with for the Sentinel. Okay, suppose this is my image. I got this image now, and now I want to just make the NDVI. Okay, so mainly NDVI is that identify what normalized difference vegetation index. Using this NDVI, we can easily identify the vegetation cover for any specific region. So in this time, for this study area of Dhaka city, I want to create the NDVI map or NDWI map or any other types of index. So today I show you the NDVI, but further I also show you the some process. Using this process, you can easily create any types of indices you can easily create. No problem. Okay. Suppose in this time I can get this type of image. So now I want to use this image and make for NDVI. So for that, previous class we talk about the Modis NDVI. Okay, basically for the Modis you can see Modis is a ready-made data set. Okay, so it's already create the band about the NDVI band. You can see Modis is the ready-made data set. So that's why in this time don't need to filter metadata or other things, don't need for the image. Suppose you can see this is the data set about the Modis. You can see about transportation. Yeah, vegetation indices. So simply click on here. Here I can get the Modis dataset. Is a ready-made dataset. Okay, 16-day global, 250-meter resolution, and this dataset is already available for the NDVI band. Okay, so that's why it's a ready-made dataset. But in this time for the Landsat, you can see there is no band about the NDVI. Okay, Landsat I can get only for this band, such as the red, green, blue, near infrared. So this type of band I can use, I can get from this Landsat. Okay, but Modis is already have this for the index formula is the near minus red band divided by near plus red band. So mainly when I use this formula, it automatically calculated the NDVI, near minus red divided by near plus red. And my Landsat image is already available for that. You can see the near infrared band. Near infrared band is the B5, and also red band is that B4. Okay, B5 and B4. So when I want to put this equation, then I can get the NDVI formula or NDVI or vegetation index. Using this index, we can easily identify about the vegetation. So just I put here this equation NDVI equal this equation. In this time, I need to calculate this equation. Okay, using this satellite image. So for that, first there's a lot of way for calculating this type of equation. So I show you for the easiest way. So further class, I also discuss about the more advanced way. so that you can easily calculate any types of equation. So for easiest way is that you can use here a function, normalized difference function. Okay, so just I simply take a variable. Suppose I put the variable name is that NDVI and call this image. Okay, because this variable image, so just I use here the image. Okay, and then use a function normalized difference. Okay, so mainly normalized difference, this function calculate this type of index such as near minus rate divided by near plus rate. You can simply suppose this function, you can simply search on the documentation tab, then you can easily get the all of those documentation about that. You can see this function mainly work compute the normalized difference between two band. Okay, so this is the main limitation. Suppose you want to calculate the index which have more than 3 band, such as EVI. You can check about the EVI formula, enhanced vegetation index formula. It including lot of constant value as well also lot of band, not only for the single band. You can see this is the EVI formula, 2.5 band 4 minus band 3 divided by band 4 plus 6 into band 3, 7.5 band 1. So in this time, this formula have some constant value as well as again lot of band. Okay, so for that, for this equation, this function is not work. Okay, normalized difference function only compute it that only for the two bands. Suppose NDVI, NDWI. So this type of index we can easily calculate using the normalized difference function. But which index have more than two band or more than constant value, different types of constant value, this index is not able to calculate using the normalized difference function. So for that, we have to put the other approach. Okay, so now you can see this normalized difference computed as first minus second divided by first plus second. Suppose near minus rate divided by near plus rate. Okay, so in this time we can simply put here the mention the band name. Okay, just put here the band name. Thus, as I put the band name is that band 5 near infrared and put here the band 4. So now it computed band 5 minus band 4 divided by band 5 plus band 4 and make the NDVI. Okay, so now let's check the result. So just use here the map dot at layer and NDVI and click run. So we can get the result as a grayscale color. You can see as a grayscale color, you can get the NDVI map. So further, you want to add here the color. Suppose I add the color. Suppose I put the suppose mean and max. Okay, and put here the plated. I just show the plated color such as blue color for water, white color, or you can use any color. Suppose vegetation use the green color. So now what is the mean and what is the max? Basically, NDVI value or NDVI index value, this range will be -1 to +1 all time. But for this study area, what is the mean and max value? I don't know. Range will be -1 to +1. But for my study area, what is the negative mean and what is the positive value? I don't know. So for that, you can simply click on this layer and then stress it, such as 98%. Suppose I just stay 98%, then it automatically calculate. You can see for my study area, -0.043. Just paste here and then 0.5, the maximum value of NDVI. Just I put that. So now just click to run and check about the result. Okay, so now we can get this type of value. So basically in this time, it represented the NDVI map. Okay, such as we can get this type of vegetation. We can get from here. Okay, and it's the water body. Suppose you want to check the pixel value. Suppose in inspector tab and click on, suppose I just click on here. So now for this, what is the value about that NDVI value? we can easily get from here. You can see this value is the negative 0.15. So that's why mainly NDVI, this range negative value identify about the water. Okay, and then a positive value, suppose high positive value, is identify about that vegetation, such as you just click on the green pixel value, then we can get the high positive value of NDVI 0.6. Okay, let's see about that 0.5 NDVI value. So it's a vegetation. And suppose for the water body, we can get the negative pixel value for NDVI. You can see negative pixel value we can get from here. Okay, so basically in this time when you can create this type of map, after that we have to download this type of map as a TIFF format. Okay, after downloading this TIFF format image, we are just use here the ArcMap software or QGIS software to create the proper map, such as this type of map. Suppose as you can see, this is the one kind of map, NDVI map for the whole country boundary of Bangladesh. Okay, so after downloading the TIFF image, just we are use the ArcMap software to create this type of title or legend. Also, all of those things we are just use here using these things from here. Okay, also you can see NDWI map for that. Okay, just download the TIFF image. Okay, and now I also show you that how we can easily download the TIFF image. You can see, so all of kinds of map we are just downloading the TIFF image, and then further for creation of the map we are just use here the ArcMap software. Okay, I have to show you the process how you can easily use the ArcMap software to create this type of map for the further class. Okay, so let's go. So in this time I talk about that how we can easily download this type of